Hi everybody, this is Tim Urdan, author of Statistics in Plain English, and in this video I am going to demonstrate how to conduct a paired or dependent sample t-test in R. If you're familiar with R already and how it works, it should be pretty easy for you to follow along with this video. If you're not familiar with this, I recommend that you take a look at one of my other videos that's called Descriptive Statistics and Introduction to R. So, paired t-tests in R. If you look up here in the top left box of the R Studio, there's a couple of lines, and these are just descriptions to yourself or to somebody that's using your data or your code to show you, to remind you like what you're doing. So these are just telling you you're going to do a paired samples t-test and run descriptive statistics on the variables in your paired sample t-test. So here is where we tell R to grab the library that holds the script for paired t-tests. So I run that, and then here is telling R the variables that we're going to be looking at. So let me run this line of code. And then down here, it's saying, give me the summary statistics for the variables in this analysis. So I'm going to run that. And the variables that I'm looking at in this paired t-test are these two down here. This is a shortening of class task wave 2 and class task wave 3. So let me tell you just briefly what those variables are. Class task refers to classroom task goals, and it is students' perceptions that in their classroom, learning and understanding the material is really what's emphasized in the class. And what I wanted to do is I want to see whether when students move from the fall semester of one grade in high school, this is in their English classrooms. So when they move from their, not fall semester, when they move from the spring semester English classroom of 1 year into the fall semester English classroom of another year, so the following year. So do their perceptions that the emphasis in their new classrooms is as focused on learning and understanding as it was in the classrooms they moved from the previous year? So when students change classrooms from 1 year to the next, they get new teachers, they get new students mixed in with them, and so the emphasis in the new classroom might be different from the old classroom. And in this case, we're looking at an emphasis on learning and understanding the material. So I just want to see whether that changed as students change classrooms from 1 year to the next. So there's 723 cases. When you do a paired t-test or dependent samples t-test, you want to make sure that you use list-wise deletion of missing data so that the sample sizes are the same. You want to have the same cases in both of these groups because you want to look at the same cases over time. And so you want to delete any cases that are missing data on either of the variables in the analysis. So when we do that, we get 723 cases, and the mean for the class task goals for the spring of the first year is 3.436,426, and the mean for the fall of the next year is 3.54. So just looking at those means, I can see that the sample mean for perceiving an emphasis on learning and understanding in the classroom has gone up a little bit from 1 year to the next. Here's the standard deviations for the spring of year 1 and the fall of year 2. You can see those standard deviations are pretty similar. Standard errors of the means for spring of year 1, standard error of the mean for fall of year 2, and the range of the confidence interval, I believe, is what the CI stands for. So those are the descriptive statistics for each of the variables that I've got in my analysis. Next, I'm going to run this line of code, and this is the one that is running the actual t-test. And down here, in this area, is the results of my t-test. So first, I get the t-value, and it's negative 3.2782. This tells me that my mean went up from time 1 to time 2. I already knew that when I looked at the means here, up here. And the degrees of freedom is 722. In a paired t-test, it is the number of pairs minus 1. So the number of pairs is 723. Number of pairs minus 1 is 722. And here's the p-value, which is 0.001095. That is lower than our general threshold alpha level of p equals 0.05. So our result is statistically significant. And R tells us you need to accept this alternative hypothesis. You reject the null hypothesis of no difference between the means. You accept this alternative hypothesis that there is a genuine difference between the means. So the difference that we observed in our sample means reflects a genuine difference in the population means. The confidence interval, which is the confidence interval of the difference between the means, which ranges from negative 0.168 to negative 0.042. Not a huge range, but both are on the negative side, which is indicative, again, that our result is statistically significant. And here is an estimate of the difference between the sample means. This is just sample mean 1 minus sample mean 2, and that is the difference between the sample means. You can, if you're interested, this value here of the difference between the sample means will be the middle value inside of the 95% confidence interval, because the 95% confidence interval is built around this difference between the sample means. So it'll be equally distant on either side of the actual difference between the sample means. So that is how you conduct a paired or dependent samples t-test in R.